Okay, at this point you've already should have done an experiment where we looked at some different substances and separated them into different classifications. So I want to talk about, first of all, one way to classify matter, and to classify matter not by like what state it is in, which is probably a common one that you came up with, is separating things into solids, liquid, and gases, but instead separate out substances based on how the matter, how the like atoms and molecules within the substance are arranged. Okay. Whoops, that skipped way too many forward. Okay, so first of all, when we're talking about matter, we should start with two broad classes where we're looking at pure substances versus mixture. So on the left-hand side, we're talking about pure substances, which is if something's pure, if you can't separate it into anything simpler by any physical process. So you can maybe separate into something simpler, but then you're doing a chemical reaction and you're making a new substance. Okay? So mixtures, however, can be separated by physical means. So you could filter something out, you could let it settle and like pour one thing off of the other one. You could let one substance evaporate out of the other. You could just simply sift through it and pull things out. So some sort of physical means is going to separate out mixtures. Okay, so mixtures are made out of more than one pure substance. Okay? We can further break down these classifications into others. Okay, one being, so the pure substances can then be broken into elements or compounds. So elements contain only one type of atom. And so elements are going to be named like things that you see on the periodic table. So you'll see carbon, so an example of pure carbon would be graphite. You're going to see in, so copper, like if you had a pure copper like pipe, nitrogen, if you had like a tank of nitrogen, okay, oxygen, tank of oxygen, like what you may find in the doctor's office, although I don't know if those are pure oxygen or not, or if it's just higher than air mixtures. Okay. Compounds are probably the more common pure substances to come across because most elements you don't find in their uncombined state in nature. So compounds are ones that contain more than one type of atom, and it has to be in a fixed ratio. So what I mean by fixed ratio is when you look at, for example, water as a compound, water is H2O, and you always find in water 2 hydrogens for every oxygen. That's the fixed ratio. Table salt is NaCl, okay? And so there's always one Na for every Cl. That's the fixed ratio. Carbon monoxide, like one of the things that's in the gas we breathe out. Whoops. CO2. Okay, so in carbon monoxide, there's always one carbon for every 2 oxygens. Anhydrous ammonia, so what the farmers put on their field is NH3. So there's always 3 hydrogens for every 1 nitrogen. Okay? A mixture can also be broken down into different kind of subcategories. Okay? Mixtures can come in 2 types. They can come in homogeneous, okay, homo being the prefix meaning same, which homogeneous is when you have 2 or more pure substances mixed so that you cannot see the individual parts. Okay? So examples would be like 14 karat gold. So that's not pure gold. It's gold atoms mixed in with like atoms of copper and silver and nickel and other things. Okay? So it's a little bit over 50% gold if it's 14 karat. Salt water, you can't see the salt dissolved in the water. You could taste that it was there, detect that property, but you can't see it. So another thing, like think of peanut butter cookies, look the same everywhere. Heterogeneous mixtures are when you have 2 or more pure substances that are mixed so that you can see the individual parts. So example, like if you have a rock like granite, has big grains of the different minerals that are in there. Italian salad dressing, there's different chunks of the different seasoning and whatnot. If you have chocolate chip cookies, you can see like the chocolate chips and the cookie are very different. Okay, so those are examples of heterogeneous mixtures. Heterogeneous mixtures can further be broken down into, when they're in liquids anyways, where you can have something called a suspension. Sorry about that. And then you have something called a colloid. So in lab today, you should have seen a suspension. Suspension is one where you kind of like muddy water, where you shake it up and it looks kind of like homogeneous, but if you let it sit, little particles of mud will slip to the bottom, and so you'll get cleaner water that's left over. A colloid is where the particles are so small, they're like microscopic, and so they're so small that it makes the mixture cloudy, so you can't see through it, where salt water is clear and you can, but the particles are so small that they don't settle out. Gravity isn't acting on them strong enough to get them to settle out to counteract just the random bumping of different other water molecules and things to keep them suspended. Okay, so that's suspension colloid. If you have a homogeneous liquid mixture, okay, then we often refer to them as solutions. Okay, so if I call something a solution, it's homogeneous. I really got to deal with this pen. Okay, so a solution is one that's homogeneous. So what makes each one of those what they are is how they are separated, or how their atoms and molecules behave. So if we think of these little circles as standing in for atoms, a compound, an element, starting with element is one, again, that only has one type of atom. So for example, this would be how an element would look. You just have one type of atom, that's it. A compound is two or more types of atoms in a fixed ratio. So here we have an example of what a compound would look like if you could see it down at the atomic level. Okay, and then these last two to the left look the same because I think something got erased off of them. So I'm just going to draw them with a pen here. So sorry about that. So if something is homogeneous, there's a mixture of different things. So we look at this yellow square, and there are white areas and kind of yellowish brown areas, but they are evenly distributed throughout, so that would be considered homogeneous. Oh, it's not letting me put that in. Well, I must have goofed something up. So anyways, this, with the way I've got it drawn now, that should go there. It's not letting me put it there. And whereas heterogeneous is where there are chunks. So these blue things are maybe little groupings of other atoms that don't evenly mix with the purple atoms below. So that's what heterogeneous would look like. The other idea I want to address in these notes is talking about physical changes versus chemical changes. So I talked to you earlier about how pure substances can't be separated by physical means, but they can be separated by chemical means. Okay? A physical change is a change that does not alter the substance. Whereas a chemical change is a change then that does alter the substance. Okay, so if we look at these two things in the boxes and try to figure out which one is a chemical change and which one's a physical change, if I look at this one, the top one, I have water molecules, so those are H2Os. And over on the other side of the arrow, I no longer have H2Os. I have some H2s, so this would be an H2, and this is an O2, and this is another H2. So here, the substance has been altered. Okay? So this is a chemical change. Whereas in the other one, I start out, even though they're grouped together, okay, and this is kind of like what, in the bottom, what water would look like if this was ice. And this over here is more like what it would look like if it was like steam at fairly high pressures because they're pretty close together. But I still have here a water molecule unit, and over on this side, I still have water molecule units. So even though the arrangement of the molecules has changed, it's water as ice, it's water as steam. There is no difference in terms of what substance it is. So this is physical. Okay, so that's a physical change over on that side. So some things to look for in physical changes. Physical changes are going to be whenever something's changing its state, like from a solid to a liquid, liquid to gas, and so forth. Physical change is just when something's like moving from one place to another. If it's simply changing form, being broken up into smaller pieces, separating out two substances from each other are physical changes because each substance is still the same. Chemical changes are ones where you're going to see new properties emerge that weren't there before. So for chemical changes, you should look for color changes. Okay, so just some things to look for with these. Changes in color are oftentimes evidence of chemical change. Changes in temperature are often evidence of chemical changes. Okay, if you're evolving gas, okay, other than boiling, so when you mix things together, okay, and if something starts bubbling, other than like if you're like boiling water or whatever, okay, gas being evolved is oftentimes an evidence of chemical change. Whenever a solid being produced, so if there's a new solid that wasn't there before, is oftentimes an evidence of chemical change. And again, that's different than just freezing the entire thing. So a new substance appearing that you can see, okay, is an evidence of chemical change. So we'll be looking at some examples tomorrow in class. We'll be doing some demos for you, and then the following day you'll be doing a lab where you can look at these. Okay, so that's all we have for notes for this time. Okay, we'll see you in class tomorrow, and hopefully this made sense to you.